An object is dropped from height h and reaches the ground with a velocity v. The same object is thrown down from the same height h with the initial velocity v. When it reaches the ground, it has a velocity v2. Which of the following relationship between v2 and v1? All right, so we're going to call the first scenario object 1, and the second one object 2. And since we don't have time, but we have velocity and position, right? We have velocity and position. We can use the third equation. So we have v squared equals v naught squared plus 2g times delta y, because we're in the vertical direction. Since we have no initial velocity here, right? This goes to 0, so we have v squared equals 2g delta y. For object 2, we'll use the same equation, v squared equals v naught squared plus 2g delta y. In this case, though, the initial velocity is v. So we have v squared equal, this is the second object velocity. This is this guy, final velocity. So v2, velocity of the second object squared, equals v squared plus 2g delta y. Okay. So let's, since this guy is equal to 2gy, let's see if we can isolate this. So we have v2 squared minus v squared equals 2g delta y. All right, so since we have v squared equal to this, and v sub 2 squared minus v squared equals to the same thing, we can set them equal to one another. So we have v squared equals v sub 2 squared minus v squared. And remember, we want to solve for this v. You can see the answers are all in v sub 2. So we have to get v2 sub 2 by itself. All right, so let's go v sub 2 squared equals v squared plus v squared. All right, so we can add up v squared plus v squared here. We're going to get 2v squared. And to get v2 by itself, we can square root both sides. Square root of 2v, and that corresponds to d.